An interval estimate is an interval or range of values used to estimate a population parameter. Since we are working with population mean, we're going to see examples about population mean. When we're talking about confidence intervals, we have point estimate, we have interval of estimate, we have level of confidence, which is denoted by C. The level of confidence C is the probability that the interval estimate contains the population parameter, assuming that the estimation process is repeated a large number of times. For each level of confidence C, you're going to define a critical value. Critical values are values that separate sample statistics that are probable from sample statistics that are unusual or improbable. There are some popular level of confidences, like 90%. When you have a 90% level of confidence, its critical value Z sub C is 1.645. When you have level of confidence 95%, its critical value is 1.96. If you have the level of confidence 99%, its critical value is 2.575. So why is it important for us? First of all, before going over the margin of error, whenever you're talking about a level of confidence, you can easily calculate your critical value. You just need to use your inverse norm on your calculator. For example, if your level of confidence is 90%, it means that 90% of the data are located here. If you have 90%, 10% is left to the left-hand side and right-hand side of the graph toward the tails. So C is 90%. 1 minus C divided by 2 is on the left, on the right. So 10% divided by 2 becomes 5%. Take a look. 0.05, 5% on the left, 5% on the right. When you're using your calculator, second vars, inverse norm, when you enter the area 5%, the z-score is going to be 1.645. That's how we find the critical value. Let's take a look at our calculator and I show you how to find it. So for 90% confidence level, we're going to go to second and then vars, and we're going to go to inverse norm. The area on the left or on the right, if your calculator doesn't show left or right, absolutely fine. You can always enter the area. In this case, the area is 5%. Since you are working with the z-score, mean is always 0, standard deviation is always 1. And then suppose you want to find the area on the left-hand side. So we're going to go to the next line, left, and then you go to paste, enter. It says, hey, this is the inverse norm because we already have the area. Enter, and you see you have negative 1.6448. This is this number on the left-hand side. So if you want to find a number on the right-hand side, which must be positive, you get 1.645. So let's take a look at the screen here. Negative number on the left, positive number on the right. That's how you find your critical values. Once you find a critical value, we can move to find the margin of error, which is the distance. Officially, we say that given a level of confidence like C, the margin of error E, which is sometimes called the maximum error of estimate or error tolerance, is the greatest possible distance between the point estimate and the value of the parameter that you're estimating. For a population mean like mu, where sigma, so this is sigma, which is the standard deviation of population, everybody, is known, the margin of error can be easily calculated. The margin of error of the mean when sigma is given to you is equal to E ZC critical value times sigma divided by square root of n. N is the sample size. When these conditions are met, we can talk about the margin of error. First of all, make sure the sample is normal, is random, and then your population is normal. Or if you are not sure about the normality of population, make sure your sample is larger than or equals to 30 in size. So let's go back to the first example. The econ researcher who collected information about the number of hours that employees are working in the county. Question says, okay, now that we have this information, find the margin of error for us. Use the data and a 95 confidence level to find the margin of error for mean number of hours worked by grocery store employees. Assume the population standard deviation is 7.9 hours. So, guys, some important information for us. C, or level of confidence, is 95% given to us. The data that we use are located here. The sample standard deviation, we can find the sample standard deviation. This last line says, I have the population standard deviation. We need the population standard deviation because we want to calculate the margin of error. Remember the formula for the margin of error? The formula for margin of error is given to us as ZC times sigma divided by square root of n. Since critical value related to 95% level of confidence is 1.96, we have it just right here. ZC is 1.96. Sigma, or the population standard deviation, is 7.9. The sample size that you can just see right here is 40. And this is the formula that you're following. Again, you have 95% level of confidence. 5% is divided up into two pieces. 0.025 or 2.5% on the right, 2.5% on the left. If you use your calculator, inverse norm, let me show you. If you use your calculator, second bars, and find inverse norm, the area is 0.025. Mean is 0, standard deviation is 1. It's on the left-hand side. And once you calculate, it gives you negative 1.9599. This is the Z value on the left. On the right, it is a positive number. Take a look. Negative 1.96 and 1.96. We need to have a positive value. The positive value is used in the formula. ZC is 1.96. Sigma is given to us in the question. Question says, hey, assume the population standard deviation is 7.9 hours. Very good. The sample size, how many people we ask? We ask 40 people. So once you do the multiplication, you get the margin of error about 2.4. What's the meaning of that? You are 95% confident that the margin of error for the population mean is about 2.4 hours. If we go back to the definition of margin of error is the maximum error of estimate or the error tolerance. it is the greatest possible distance between the point estimate and the value of the parameter that is estimated. So that's how you calculate your margin of error.